Yeah. So this question is 58 question number 58 from gate 2022 session 1. So in this question they have asked you to calculate the bed width. So let me read the question carefully. So they have given depth of let me read the question. So depth of water flow. So depth of water flow in a 3-meter wide rectangular channel is 2 meters. The channel carries a discharge of 12 meter cube per second. Take acceleration due to gravity as a 9.8 meter per second square. This is the given data. Now the question is that the bed width in meter at contraction, which is just cause the critical flow, is how much dash dash without changing the upstream water level. So let me give you what they have asked in this question. Imagine this is a channel. This is a channel in a plan view. Let me draw another thing. So this is a sectional view. So how much is the width? They have mentioned 3 meters, and the current depth of flow is 2 meters. Okay. So let's say this. Let me take this is a section 1 and let me mark it as a critical section C, and this cross section is at section 1. Okay. So now what they have done is that they wanted to reduce the bed width. Let's say this is B minimum. Okay. So now they have asked you to calculate what is this value without changing the upstream water level, and it means that the channel should carry the same discharge Q, but it should have a minimum width. So these kind of actions we will perform when we want to reduce the cost of the construction and other things. And we need to solve the purpose also, because like if there is any like crop land any downstream of this channel, we should serve this same amount of discharge for the crops. But yet suppose if you want to reduce any economy and other things, we will perform these kind of actions. So let's see how we can. Let me give you the theory part here. So the critical state of flow has defined as the condition for which Froude's number is equal to unity. I think all of you know what is a Froude number. Froude number will be V upon 0 y, nothing but inertia force by gravitational force. So this I have written for the rectangular channel. Rectangular channel. So more general formula will be Fr square equal to Q square T by G into A cube. I hope I am correct. This is a more general formula, but for the rectangle we can simplify as V by root over Gy. So in this case, Froude number will be 1 for the critical flow. A more common definition is that the state of flow at which the specific energy is minimum for a given discharge. So what is specific energy? Specific energy is nothing but energy per kg of water at any section of channel measured with respect to channel bottom. I think all of you know, it's like we have this potential energy, kinetic energy, pressure energy, and other things. So here in open channel case, this we called as a specific energy, and here we neglect the potential energy as 0 because we are calculating the specific energy with respect to the channel bottom. So Z will be 0 only. So and this particular will be velocity kinematic head, and this is a pressure head. This is pressure head. So at critical state of flow, the specific energy is minimum or nothing but dE by dy equal to 0. So by solving this dy equal to 0, we will get some relation between the EC equal to depth of flow. So all these relation, all these derivations are out of scope now. Just remember what is the critical state of flow and what happens at because this particular point they may ask in one more question. So at a critical state of flow, the specific energy is minimum. And this definition also you should remember. Sometimes they may ask for one more question. So the critical flow is nothing but a state of flow at which the specific energy is minimum for the given discharge. Okay. So imagine let B minimum is the minimum width of channel for which flow is possible without any change in upstream flow condition. Because in the question they have asked, we should calculate the width of channel without changing the upstream flow condition. So we should keep this point in mind and we will calculate. So how we can calculate the B minimum? So we have this formula. I have shown you already. This will be kinetic head and this is the pressure head E1. And so when B equal to B minimum, this C1 will become EC. That is nothing but specific energy will become critical minimum specific energy, critical energy. So the upstream depth of flow continues at Y1 because we should not change the upstream depth, and the depth of flow at a downstream section will be critical depth corresponding to a specific energy of EC1 equal to E1. So by like I already shown you by solving this particular equation, we will get the relation between the EC and YC. So it will be 3 by 2, not 1 by 2. Sorry. EC will be equal to 3 by 2 of YC. So this derivation you can find in any textbook, but this is not this is out of scope now. So just remember this formula: E is equal to 3 by 2 of Y. So we will get this particular equation, and from there we can reshuffle the terms, and we can get a B minimum as square root of Q square by G into 2 by 3 of EC whole cube. Remember this formula and note down this formula. This formula may be useful to you. Here this 2 by 3 is a Y. Okay. Yeah. So now solve the questions. So depth of water flowing in a 3-meter wide rectangular channel is 2 meter. So here width is 3 meter at section 1 and depth is 2 meter. The channel carries a discharge of 12 meter cube per second and the G is 9.8 meter per second. So this is acceleration due to gravity. So they have asked you to calculate what is a bed width at a contraction which just causes the critical flow, which means that E is EC, just a critical flow. So let first note down what are the given data. Given the Y1 is 2 meters, B1 is 3 meters, discharge is 12 meters per second, acceleration due to gravity is 9 meters per second square. So step 1. What is the step 1? You need to calculate the specific energy at upstream section. E1 equal to Y1 plus Q square by 2 into G into A square. So you will write 2 meter depth plus 12 square divided by 2 into 9.8 into here I know area of rectangle will be B into H na. So here it is like depth. We need to calculate only flow depth. So 3 into 2 whole square it will be 2.204 meter square. So once you know the E1, so at when B equal to B minimum, E1 will become EC. So with this relation, with this condition, we will use the same. I have shown you this formula in the previous slide. So the bed width at a contraction B minimum when the flow is critical E1 equal to EC. So by substituting the same all these formulas here, so 12 square equal to 144. So divided by 9.8 into 2 by 3 into 2.203 whole cube, we will get a 2.152. Here you see, this is also one mistake we make. They told round off to 2 decimals, but here I have shown you 2.152 meter square. So please note down when they specifically mention 2 decimals or 3 decimals, you always mention those decimals. Suppose if you mention 2.1 meter, sometimes the correct range may be different. So sometimes the correct range may be 2.1 122, 2.15, then you may be wrong. So please read this particular point carefully and answer accordingly. So